Hello everyone. Today we're gonna discuss some of TCP and also RFC 793 scans, practically on wireshark PK files. It is a very interesting topic. But firstly, what we're gonna do? Firstly, we start with the ARP scan. But let me talk about ARP and why we use it. ARP stands for Address Resolution Protocol, and it's an important protocol that plays an important role in networking world. Okay, when networking with your network systems, this protocol helps to identify specified network devices and find their addresses. And actually, it works and it operates on layer 2 of the OSI model. It's used to mapping the IP address into MAC address. When one device wants to communicate with another device in a local area network, the ARP protocol is used. And actually, ARP protocol finds the MAC address based on IP address. An IP address is used to communicate with any device at the application layer. But firstly, and if we talk about ARP attacks, for example, we can say ARP spoofing or ARP poisoning. What's ARP spoofing? In the context of ARP spoofing, there is a bad guy, there is an attacker, tries to mask them, tries to masks him or her as a legitimate device. Okay, for example, if we write arp spoof -i and whatever interface, then -t IP address, and in this case, for example, the attacker tries to show himself as a default gateway to the target device, and all the actions and all the networking capabilities and all the requests go to internet through our attacker machine. Our attacker machine treats like a proxy in this case. So we're gonna answer a lot of questions here, but the questions are pretty same in every single actually PK file. Firstly, let me just open this pcap folder, and here we go. The first one is called ARPScan. Let's click on it. Okay. The first question is identify the attacker IP. Firstly, let's here they are basically ARP protocols, but there are some other protocols in this pickup as well, such as DNS, and that's why let me filter this pickup. Only shows us the ARP's request. Okay, then press enter. We have 520 packets related to ARP packets, ARP protocols actually. So as you can see here. If you are familiar with our protocols, you can identify it easily. As you can see, it says who has 192.168.131 and 3. Tell this device. Tell this device. Tell this device. Okay, this is the attacker IP. 192.168.131 and 138. Actually, it sends broadcast request to all devices inside our network, and that's the suspicious activity. Okay, and that's why our attacker is this one. Let's write it down. Sorry. Okay, then let's keep on. Sorry for misunderstanding. Identify the target IPs. Target IPs are basically these addresses. Okay, starts from 192.168.131 and 1, and until 192.168.131 and 255. 255 is the broadcast address for this network, and the answer is all of the IP addresses except this one. Okay, because this one is the attacker IP address. Okay, identify the total of scanned ports. For this kind of purposes, statistics and conversation tab is pretty cool section in the wireshark application. Let's go with conversations, and we can see here. We have sorry for that. Sorry for misunderstanding. Actually, these all of them are tricky questions for ARP scan because there is no point in searching for ports or open ports, closed ports in ARP scan because, as I mentioned earlier, ARP works on the second layer, data link layer of the OSI model, and we assign port numbers on the layer 4 transport layer, and that's why it's meaningless. Okay, they are just tricky questions. The answers for all of them is not given, not answered, NA. Okay, just write it down like that. Okay, the next one is called FinScan. Okay, it's very interesting scan type because it's one of the types of RFC 793 scans, and RFC 793 scans distinguish from TCP scans. For example, let's say let's take an example, full TCP scan. In a full TCP scan, if we wanted to identify open ports, then we should look for a three-way handshake, right? The client sends SYN packet to attacker or to the server, and the server sends SYNAC, and the client finally sends acknowledgement packet. This is the sign that this port is open, right? But if client sends SYN, but after the server sends reset packet immediately, it's the sign that this port is closed, actually, right? But there is a difference, open port and filtered port in TCP scan, and we can easily identify it. If the port is filtered, there is no response back to client or back to server. But in RFC 793 scans, if the port is open or if the port is filtered, in both cases we can't see any response from the server side, and that's why we can identify this port is either open port or is either, let's say, or filtered port in RFC 793 scans. And FinScan, XMessScan, or null scan or zombie scan are kind of types of RFC 793 scans. Okay, I just want to mention it beforehand. Let's go to FinScan pickup. The first question again asks for the attacker IP. Okay, just let's close this one. Okay, if you wanna find the attacker IP, just write tcp.flex and .fin double equal sign. It's 1. Okay, it means it shows the packets only has fin packet. Okay, fin scan. Sorry, fin flag. And if we press the enter, we can see all the source IPs are the same, 10.10.10.3. This is the attacker IP, actually. If you want to find the target IPs, here it is, 10.10.10.4 and 10.10.10.2. These are the two target IPs, actually. Let's write them down as well. Now, if we want to find the total of scan ports, we should look for it in the conversations section. Let's go to statistics and conversations, and here I click on TCP, actually, because this fin flag fin flag belongs to TCP. Okay, and we have 37 packets here, and we should only look for unique port numbers, not all of them, not duplicate ones. Okay, As you can see, we have 80. This is the default web server port. This is RDP port. This is SSH. This is FTP. This is Telnet. Okay, just count them uniquely. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. And all of them, actually, rest of them are duplicate ones, and that's why the answer for us for our question is 10. Now, let's identify the open ports actually. If you wanna find the open ports in FinScan, as I mentioned earlier, like I said, FinScan is one of the types of RFC 793 scans, and that's why we can't identify this port is either open or filtered. But if you wanna find the open ports, it's a smart idea that firstly let's look for closed ports because they are easy to find them. Okay, it's easy to find them. How are we gonna find closed ports in FinScan? Actually, let's understand the logic. If the port is open, okay, no, if the port is closed, the attacker sends fin packet to client, and client just sends reset. Okay, the logic is here. If client sends reset message, it means it's closed port. But if the attacker sends reset message, it means it's open because already we have communication between them, and an attacker tries to reset the communication. It's okay. It's a sign of the open port, uh, uh, but there is a problem if the client tries to send reset packet immediately before a communication. It's the sign of closed port, and that's why let's write TCP dot flex and dot reset doubles equal 1, and also we should write and IP ADDR or IP source address equal. This one should be target IPs for closed ports, as I mentioned earlier. Let's write this like this, because we have two target IPs. One of them ends with 4 and one of them ends with 2. And let's write them inside the brackets to make the syntax much more accurate, like that. Okay, press enter. As you can see here, we have 3 ports closed, because you can see here when the attacker tries to send FIM packet, it immediately sends reset acknowledgement packet to the attacker, and it's the strong sign of this port is closed actually. Okay, they are 443, 110, and 3389. Okay, which ports are open? No, my bad. There are closed ports. Okay, after finding closed ports, let's find out open ports. What we're gonna do, we just change the IP, the source address of the IP to the attacker IP address from the target IP address. Okay, like this. And we don't need the brackets anymore. Okay, let's enter. It doesn't show anything. It's weird actually. So, if you wanna find out, sorry for that. In FinScan actually, if the port is open, we can't see anything. Okay, and that's why we have actually 10 ports totally, right? And 3 of them are closed. And then let's go to identify in the conversations section. Okay, as you can see, this one is closed, this one is closed, and this one is closed. And then we have this one, this one, this one, this one open. Then 21, 22, 23, and then 139, 445. These ones are open on this IP address. Let's find out if why. Okay, 25 as well. 25. 25 and 21, 22, 23, 139, 80, 445. Okay, these ports are open for the IP address ends with 2. Okay, ends with 2. And what about the port numbers related associated with the IP address which ends with 4? As you can see, all of them here. We have 80 actually, and then we have again. But let me find out what ports we found out which ports are closed, right? But we don't find in which IP. They are all closed in 10.10.4, right? And then they are open in this IP address. Let me correlate this one, and actually this one, because these port numbers are closed in this IP address. Okay? And then let's write open ports without 110, 443, and 3389 in the IP address ends with 4. Like that. Unfiltered ports are pretty same. Let's just copy that and paste it below. Why I just copy and paste for open and filtered ports? Because as I mentioned earlier, we can identify this port is filtered or this port is open in RFC 793 scans, and that's why there is no problem. Just copy and paste them. Okay. The key point is finding out the closed ports and what these closed ports, which IP address does this closed port belong. Okay, it's the key point for whole problem. Okay, then the next one is full TCP scan. This one. Okay, it's very easy. Firstly, let's identify the attacker IP address. Let's just write down TCP here. And as you can see again, the source IP addresses are pretty same. Okay, most of them ends with 138, and this is the attacker IP address. Let's write here 192.168.131 and 138. And then let's find out the target IP addresses. As you can see, the target IP addresses ends with 134 and 135. Okay, just like that. Let's write them down as well. Okay, let's find out the total, the sum of scanned ports, the total scanned ports. Let's go to conversations again here. And let's find out the unique port numbers. 23, 80, 23, and we are, okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. there are again totally 10. Now, let's firstly find out the close ports. As I mentioned earlier, we should write TCP and flex.reset equal 1 and sign, ampersand sign. Inside the brackets, we should write IP source equal 192.168.131.134 or IP.source double equal 192.168.131.135. Okay, this means that if thanks to this filtering, we can identify that this IP address is reset, sends reset packet. Okay, and this is a sign of these ports are closed or these ports are not. Let's press enter. As you can see, again the same ports 110, 443, and 3389 are closed ports for only the IP address ends with 135. Okay, let's write them down here as a closed ports 192.168.131 and 135, and the port numbers are these ones. Okay, and if you want to find out the if you want to find out the open ports in TCP scan, it's very easy. It doesn't look like the RFC 793 scans because how can I say, it responds us. Okay, we should look for three-way handshake: SYN, synchronization acknowledgement, and acknowledgement packets. And that's why let me write tcp.flex.syn double equal 1 and tcp.flex.ac equal 1. Then press enter. And these port numbers are open port numbers for 192, 168, 131, and 135. There is no open port for the IP address ends with 134. Let me prove that. As you can see, it's blank. But when I write 5, it shows some port numbers. Actually, the port numbers 22, 445, 80, 139, 25, 23, and 21 are open ports for this IP address. Let's write them down as well. Firstly, the IP address, this one, and the port numbers. Okay, the port numbers. Okay, I write it down, all of them. So, and let's just and if we it's just a simple math. If we have totally 10 ports and actually 1, 2, 3, 4, 5, 6, 7. If seven of them are open ports for the IP address ends with 135, and 3 of them are closed ports for this IP address, and it means all of the port numbers for the IP address ends with 192, ends with 134. All of them are filtered ports. Okay. 21, 22, 23, 25, 80, 1110, 139, 443, 445, and yeah, let me check this. Yeah, I wrote all of them. Then let's talk about half TCP scan. How we can differentiate half TCP and full TCP scan? If it's full TCP scan, there are SYN, SYNAC, and acknowledgement packets. Okay, but if it's half TCP scan and there is, it means there is no acknowledgement packet anymore. The client sends the SYN packet to the server, and the server replies the client SYN packet with SYNAC packet. It stands for synchronization acknowledgement, and finally the client sends reset package after the communication has been successful. It's the half TCP scan. Okay. Let's open it. No, half TCP, this one. Okay, let me. Great. If we wanna find out the attacker IP again, let's try TCP simply. And as you can see, most of them are again ends with 3, and this is the IP address for attacker. 10, 10, 10, and 3. And the target IP addresses ends with 2 or 4, and this is the target IP addresses. Okay, if we want to find out total of scanned ports, let's look at again the statistics conversation part, and here you can see all of them. Actually, I counted beforehand, and there is no point in wasting time again. There are again 10. Okay, and let's find out which ports are closed. The filter is same again. TCP flags dot reset equal 1, and IP source address okay. These port numbers are closed for the IP address and with 4. Let's write them down. Okay, let's find out open ports. And IP source this time should be the attacker IP address. Double equal sign. Okay, as you can see here, these ones are open ports for the ends with IP address ends with 4, and these ones are the open ports with the IP address ends with 2. First, let's write them, and first let's write the port numbers for the IP address ends with 2. Okay, 23, 23, 23, 21, 22. Actually, all of them, right? All of them, yes. (23), 22, 23, 25, 80. Okay, and for the IP address ends with this one. We have again the port numbers, but except these 110, 443, and 3389, because these ports are closed ports for this IP address. Okay, if we want to find out the filtered ports in half TCP scan, we should look for